Welcome to Understand the Math. Let's walk through an example of finding the equation of a tangent line to a curve. Suppose we have a point P located at 5, 3, and it lies on the curve y is equal to the square root of x plus 4. We're then told that point Q, located at x, square root of x plus 4, is some point on the curve. We want to find the equation of the tangent line at point P. I think it's always good to make a graph when you begin this type of a problem so that you can visualize it. I made this graph on Desmos. It's a free graphing tool that I highly recommend using while you're studying calculus. Point P is located here at the point 5, 3. And point Q is going to be located to the right and to the left of point P. Let's write down that P has coordinates 5, 3, and then Q has coordinates x, square root of x plus 4. Our first step in finding the equation of the tangent line at point P is to calculate the slope of the secant line. I think it always helps to write down your formula first. Our formula for the slope of the secant line is m sub sec is equal to m pq. That's just the slope of the secant line between points P and Q. And that's equal to the change in y divided by the change in x. We can find delta y divided by delta x by looking at our points P and Q written in the upper right. Our change in y is going to be the square root of x plus 4 minus 3. All divided by the change in x, which is x minus 5. Our second step then is to calculate the slope of the tangent line. Let's start by writing down that formula. M sub tangent is equal to the limit as Q approaches P of the slope of the secant line. So this is the limit as the x coordinate of point Q, which is up here on the right in orange, which is x, goes to the x coordinate of point P, which is 5, of the slope of the secant line. And now we just have to copy down the formula, which we just found, which is the square root of x plus 4 minus 3, all divided by x minus 5. Now here's where the hard work begins. When we compute the slope of the tangent line, we're going to let x approach the point 5. So we have to figure out where x should start. I'm going to start with point Q being to the left of point P. So I'm going to start with x being at the value 4.5. We're then going to calculate the slope of the secant line. What you have to do now is take this x value and put it into this formula. When we do that, we get 0.169048. Now we're going to let x get closer to 5, so I'm going to make a big jump, and I'm going to say x is 4.9. Plug that into the calculator, and you get 0.167132. Now we're going to get closer to 5, so we're going to say x is 4.99, and we get 0.166713. And now let's let x be equal to 4.999. That gives us the slope of the secant line is 0.166636 and then 71. Now we're going to let point Q be to the right of point P. So we can start with x being 5.5. And we'll compute the slope of the secant line just like we did before, We take 5.5, plug it into our formula in green, and we get 0.164414. Then we let x be 5.1. We get 0.166206. And then x is 5.01. And our slope is 0.166620. And then lastly, our x is 5.001. And we get that the slope of the secant line is 0.1666. That's 4 sixes and then a 2. Now we can find the slope of the tangent line. The slope of our tangent line is going to be what we call the limiting value of the slope of the secant line. As x got closer and closer to 5, our slope of our secant line went to these values. And we can say that those are equal to 0.1666 with the 6's repeating. And you might recognize this number. It's equal to the fraction 1 over 6. So the slope of our tangent line is equal to 1/6. Our last step now is to just write the equation of the tangent line in the form y is equal to mx plus b. This is actually the easiest step. Let's write down our equation in point slope form. Y minus y1 is equal to the slope of the tangent line times x minus x1. Now we're going to plug in that x1, y1 is our point 5, 3, and the slope of our tangent line is equal to 1/6. This gives us y minus 3 is equal to 1/6 x minus 5. Now we want to take this equation and put it in slope-intercept form. We'll pull the 3 over to the right and then multiply out the 1/6. This gives us y is equal to 1/6x minus 5/6 plus 3. We can think of our 3 as 18 over 6 so that we can better add our fractions. And this gives us y is equal to 1/6x plus 18 minus 5, which is 13. So we get 13 divided by 6. And that's the equation of our tangent line.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.